Okay, let's discuss the four different types of, all the different types of quadrilaterals. A quadrilateral is any four-sided shape. And the first type of quadrilateral you need to know is a parallelogram and what makes it special. Opposite sides are always parallel. There are three special types of parallelograms. You have a rectangle, and what's special about the rectangle is it has four right angles. You have a rhombus, and what's special here is a rhombus has four sides that are all the same length. And then the combination of the two is a square. A square has four right angles and four congruent sides. The last two types of quadrilaterals you need to know is a trapezoid that has one set of parallel lines, and then a kite. And you see a kite is a lot like the type of kite that you actually fly, and they have consecutive congruent sides. These two sides are congruent, and these two sides are also congruent. Now, all the different properties here, you don't have to memorize the big list. All you need to know is the symmetry that these shapes have, and you can actually derive the different properties from that. A parallelogram, all the different types of parallelograms, including rectangles, rhombuses, and squares, have what we call rotational symmetry. When you draw the diagonals, you can actually find the center of rotation, which is actually right here. And what a rotational symmetry means is you could spin this shape around 180 degrees around that center, and you're going to get the exact same shape back. Meaning, if I were to spin this shape around, I know that this side would line up perfectly with this side, so they have to be the exact same length. I know that this angle, when I spin this thing around, would line up with this angle, meaning that they're the exact same size as well. Different reasons we could actually prove this, but spinning this around, we know it's the same size as that, and so on and so forth. Rectangles work the exact same way. If I know this side length is 7, if I spin it around, I know this is 7. Now, rectangles also have two lines of symmetry, and you can see those dotted here, meaning that if I were to flip this across the line of symmetry, I know if this is 7, that this up here would also be 7. And for the exact same reason, because this is 7, this would be 2. But also, you have lines of symmetry here, meaning those would be the exact same thing. In addition to that, let me get my lines back. In addition to that, if you knew the measure of this angle right here, let's say that was like 50 degrees, then obviously this would also be a 50-degree angle. And you can actually see the isosceles triangle inside there. Rhombuses also have two lines of symmetry and rotational symmetry. Something special about a rhombus, notice that these two angles right here form a straight line, and since they have to be the same measure, we know that they'd both be 90, so the diagonals bisect each other. Because of the lines of symmetry, we know those two angles would be the same. We would know that these two angles would be the same, and because of the symmetry, these would be the same. So again, if you know about the symmetry, you can find all the different side and angle measures from just that. And then a square has all different types of symmetry. You've got rotational symmetry in addition to actually 4 different lines of symmetry. So here's what that creates. So in a square, we know that this is 90, and since this is a line of symmetry, it would actually cut it into two 45-degree angles. For the same reason, you actually have two 45-degree angles over here as well. The diagonals bisect each other, so you have actually a 45, 45, 90 special triangle here. This would split that 90-degree angle in half, so that's a 45 and a 45 as well. So you also have smaller 45, 45, 90s, and you can use your shortcuts there. Now, the only type of trapezoid that has symmetry would be what we call an isosceles trapezoid. If these sides were the same, then you would have a line of symmetry down the middle to where these two angles right here and here would be the same. These two angles up here would be the same. This line of symmetry would split this into two equal pieces and so on and so forth, but only if it's isosceles. And then finally, a kite has one line of symmetry, meaning that these two angles would have to be the same. Again, we already know those two sides are the same. These two sides are the same. This line of symmetry would actually divide this thing into the angles. Like if this were the whole angle up here was, let's say, 100 degrees, we would know that these angles here would be 50 degrees apiece, and so on and so forth. So again, if you learn the symmetry of these different shapes, it'll show you what all the different properties are that you need to know.